So purpose of today, we're going to finish up our review. If there's time at the end of class, we can tackle one of those extra problems from one of those two sites. I've noticed that some people are starting to get some CADIS scores, which is great. There's starting to be some competition for the TA. You're going to have to keep him on his game throughout the quarter, which is good. It's very good practice. Last time we were discussing enums and talked about how you could use an enum to create a mapping between integers and some values that have some more meaning, to add some more meaning to your code and make it more readable. The more English you can put in a programming language, the easier it's going to be to read. It's not very easy to read digits, zeros, ones, twos, but as soon as you can describe that with some kind of English concept like ordered, ready, and delivered, then you end up with significantly more readable code. You can see we've discussed some problems with using integers for this enum, and your code readability suffers a lot. And in the future, you are going to be not the only person responsible for your own code. There are going to be other people who have to read your code, and future versions of yourself who are going to have to come back and look at your code. My challenge to all of you over the next 24 hours, go back and look at code that you wrote in 210 or some equivalent from wherever it is that you came from when you took your first programming course. Go back and look at the programs that you wrote. And with the knowledge that you have now, you're going to wonder what you were on when you wrote that. There's something that is just not going to make sense, needs further elaboration. You really have to sit there and think about what the code is before figuring out what it is that it does. So the more you can prepare someone else or a future version of yourself to go back and look at that code and understand it very quickly and efficiently, then that will serve you well. All right, so next topic is iterators. Have we seen iterators before in any prior class? No? All right, it's a reasonably important topic that comes up a bit in Java, but really starts to become necessary as you're dealing with other languages that use them more than Java does. Java uses them, but a language like C++ uses them significantly more. But this is an object that's going to help us as we loop through a collection. And this is not particularly needed if all we're doing is reading from the values in a collection. So for instance, you have a list and you want to print all the elements of the list. You can do so in a for loop. Have we seen a for each loop or know what a for each loop is? Just to refresh people about what that might be. So we have some list. It doesn't really matter what it is. We'll just call it some variable we're going to call a list. And you can say something like for, and this is, maybe a type integer. For it says for integer I in list, the colon can be read as the word in, that basically says for each element of the list in this list. So every time you loop through this, you're going to be the next element, the next element. So we'll start with index 0, then index 1, then index 2. But note that we don't have to specify how long this list is because the collection already knows how long it is. This is actually using an iterator object when you do this underneath the hood. But it's not communicating that, and you don't need to know that in order to use a for each loop. But if you make your own collection type or you use other collection types like a linked list or an array list, and you want to be able to iterate through them in a way that you're writing to the object while you're looping through it, imagine trying to add to the list or remove from the list as part of this. I urge you to go try to do that and see the kinds of mistakes that you'll run across, the kinds of exceptions that will be thrown that you don't necessarily expect to be there. And that's because you're modifying the list as you're going through it. That creates problems. So an iterator is the kind of object that you will use to get around those problems. So you do not need to use an iterator if you're only reading values from the collection. But as soon as you're writing values to the collection, then you will need to use an iterator as you loop through it. Why do we think that might be? What intuition do we have that says that we might need some additional logic to be able to modify a list as we're printing out the elements that are in it, or something of the sort? So a basic example of this might be, we have a list with the numbers 1 through 10. We're going to iterate through every element of the list and print it out. But every time we reach an even number, we're going to add the next number to the end of the list. So we would see 1, 2, and as we see a 2, we're going to add an 11 to the end of the list. 3, 4, we're going to add 12. 5, 6, we're going to add 13. But we still want to print every element of the list, and eventually that process would terminate. We catch up to the end of it. But when we start, the length of the list is different from when we end. It's even harder if you're removing things, because if you think the list is of length 10, and every time we reach an even number, we're going to remove the last element of the list. How do we know when to stop? So an iterator has two things. I guess we should first talk about how to get an iterator for a collection. Every collection object is going to have an iterator method. So if we had some kind of array list called list, you could say iterator I equals list.iterator, and it returns an iterator object for that. Then iterators have two important methods associated with them. The next and has next methods. So just like with a scanner, that's probably where you've seen something like has next and next. Is that right? You've used has next and next as part of a scanner to figure out something like, is there another value to read from? If there is, then go read it, go get it, do something with it. So very similarly with an iterator, you can say, if the collection has a next value, then go read the next value. And this will allow you to get around the issues that you run across when the collection is changing size as you're modifying it. So an iterator is a good thing to know it exists. It sounded like quite a few of you have not played around with iterators. Another challenge for you between now and the start of next week, go write a program that has some kind of collection, an array list, some other kind of collection that you've seen. If you haven't seen other collections, just use an array list. Make an iterator and see if you can get a program working that adds to and or removes from the list in the middle of a loop. And to do that, you'll want to use the iterator, but just play around with that concept and see when it breaks, why it breaks, how using an iterator ceases that if you're using the iterator correctly. Questions on iterators? All right, next topic we'll cover then is preconditions and postconditions. Who's seen the concept of a precondition and postcondition before or know what they are? A few people. Any one of you want to explain what you think a precondition or postcondition is? It's perfectly okay. So a precondition is logic that needs to be true before a particular code segment starts. What assumptions is this code making about where we are in our logic right now? So for instance, if we want to remove an element from a list, what assumptions are we making?
A, that the element exists, and B, that the list exists.
That the list has some number of elements in it, right? In order to remove what's at position 1, the list needs to have that many elements in it. So if we think about it, you can call remove on an empty list. What do we expect to happen if we call remove on an empty list?
Nothing.
Is that?
Would it remove some garbage?
It's actually going to throw an exception. But the only reason it's going to throw an exception is that somebody wrote an exception there that says we broke the contract between the remove method and what the person is trying to remove from the list. The method cannot continue to do what it was supposed to do because some reason that is inherent in the call and the list object. So we cannot fulfill the contract of removing an element from a collection if the collection has no elements in it, or not enough elements to have an element at that associated position. So that's a kind of precondition. If you can think about when you're writing a method, when someone calls this method, when is it not going to work? When am I not going to have the logic to be able to do what this method is supposed to do? Those are your preconditions. Those are the things that you want to specify and throw exceptions for. Because that communicates back to the user something went wrong, but it tells them exactly what went wrong because you can specify the exact kind of exception. And you can throw, as part of throwing an exception, you can print to the screen as part of that exception, you return some text. So you can take this idea of precondition was violated and tell someone the list was not big enough. You can add logic to your exception to communicate that back so that someone who tries to call remove on a list then knows why it was not successful. It's not just your program crashed because you suck. It's your program crashed because you actually get that information back, and that helps to be able to know why the code failed. So here's another example of a precondition. The value of the object passed in the first parameter must not be null. If you're going to pass an object as a parameter, you expect to be able to dereference that object. You expect to be able to look at its fields, its methods, and be able to call those associated, figure out the getters of the fields and interact with that object in some sense. If the object is null and you try to dereference it, you're going to get a null pointer exception. So we want to check for that before we try to dereference it, because once you dereference an object, your program must crash. We talked about this with exceptions. Try to follow this object that points at a structure, and if that structure is not there, when you say go get this structure, now we have to crash the program. But if you check for null before you do that and say, is this object null? That will not crash the program. That will return a Boolean, true or false. If it returns true, we can, instead of crashing the program, throw a non-crashing exception, terminate the method, and throw that back to the user that says something went wrong. And that way the user doesn't lose all of their data. It's only crashing a program should be a last resort. So in this case, we don't have to crash the program if for every method we write down our preconditions and we check all of those preconditions and throw the associated exception that says that this was violated. Does that make sense? So what should be done if it is? Throw an exception. A post condition is some logic that must be true after a particular code segment successfully completes. And what that means is usually at the end of a particular method. If you had a sort method, there would be some post conditions about how things are stored in that collection. You would expect them to be in sorted order. If this successfully completes, then we have completed the contractual obligation between the method and its caller. So preconditions, things that need to be true at the start of a code segment, post conditions, things that should be true after the completion of that code segment. This is important because this feeds into how we document our code. So Java, the language, actually has a comment specification called a Java doc. Have we heard of Java doc comments before? Yeah, I see a few people nodding their heads. Who's never heard of Java doc or used it before? Quite a few people. That's perfectly okay. But it also helps to be able to comment your code in a way that is a standard across everyone who uses Java. That means that when you go look at somebody else's code, you can go look for particular comments in a particular form at a particular place where you don't have to go read through long thousands of lines of code looking for particular comments that explain things. So we're going to learn about the actual format of these comments, and that's going to become necessary for this class. Reason being, it looks really good to potential employers if they look at your code and they see, oh, this person wrote in JavaDoc. That means they know and understand JavaDoc, or they copied this code from the internet. So the comment will precede a class. It will precede every field in an object, every constructor method, and every behavior method in that object. So there will be a place in before that will have a particular comment and a particular format that will explain some things about the class, the field, the constructor, or the method. How this is identified, any IDE will look for this. We're used to block comments starting with /*. If you start your block comment with /** instead, it will identify that comment as a JavaDoc comment. After that, you will have a high-level description in English about what the class or field or constructor or method does. This should not be too verbose. Very high level. This does not need technical detail. It's just a, what does this do? Then, if it's a method or a constructor, you will list every parameter on its own line, along with a description of what that parameter represents in English. The syntax for this is you will say @param, the variable name of the parameter, and then an English description of what that parameter does. So @param age, the age of the person object. Then you will list each precondition for that method, assuming that it's a constructor or a method. And again, not everything has preconditions, but if there are preconditions, you'll want to list them in the following way. You will say @precondition and a description of the precondition. You'll also want to map every one of these with some kind of exception that is thrown in that method. If there's a return value, you want to describe what is being returned from that method. If it does not have a return, if it's void, again, these are just, you skip each of these that are not relevant to whatever the code is. So not all methods are going to have all of these, but you want to make sure they are there if the method has parameters or preconditions, a return value, and this is done with @return, description of the return. You will have a post condition, or list all of your post conditions. And as you might expect, this is @post condition, the description of the post condition. All of this helps with your code readability. It helps with the ability, if you're going back to this, to understand what every method does. And it means that your code is accessible, especially to developers who may not understand this language at a very easy, writable, readable level. Everyone reads, okay, that's a huge assumption. Everyone reads English, but everyone who's going to read your program will probably read and write in English at least as well as they do in whatever language, their programming language you're using. You'll also want to list every exception that may be thrown. This tells you what exceptions are expected from the logic within your method. And this is just @exception. You can also use @throws. And then you list the exception name. So if it's a null pointer exception, you'll want to say @exception, null pointer exception, and then the reason that that exception may be thrown. If this particular parameter or object is null, then this exception will be thrown, something like that. Questions so far? Do we buy the usefulness of these comments? That you're getting yourself in a lot of work. There's a lot of extra work here, making sure that you're doing this. So a lot of novice developers don't buy on to the need to do this. So I want to make sure that either we're all on board, or at least we see some value in doing this, even if you don't necessarily yet buy that this amount of work is worth the amount of effort that you have to put into it. At the top of each file, you will put @author and your name. For this class, @collaborator and anyone that you collaborated with on a particular assignment. This lets me know that if there is some high-level similarity between the files that are submitted, you talked about it with each other, which is perfectly fine. I've said that it's perfectly fine to talk about code at a high level. I'm not looking for them to be exactly the same, but at the same time, if they share some high-level abstracted ideas, then this just says, I talked with this person and that's the reason why they look so similar or have the same kind of form. Again, perfectly fine. @date and the current date. This will be very useful if you go back to this at a later time. It helps potential employers be able to see, oh, this is what you produced when you were a sophomore. And then they don't have the particular requirement of, wow, you just produced this? And then @course, this will just help in the future to be able to look back and identify when is it, what course were you in that you made this. This is just all for future reference. And it helps a lot once you're trying to organize your code portfolio when you're looking for a job. All of your work will have the associated course number on it. You'll easily be able to reference and figure out, where did this come from? What was I doing? What knowledge did I have when I produced this code? Very helpful both for you and potential employers. And that's it. So top of each file, and then everything at the start of each method or field or constructor, you'll want to have an additional comment with those associated things. There's more to JavaDoc than just this, but these will be the requirements for this class. There are a lot more potential tags, but it also allows you to search your files for things like, where are the methods that have JavaDoc comments? Any questions before we move on? All right, one of the biggest points of confusion for early Java developers, the static keyword. What is the static keyword? Yeah, okay, so that's a good place to start. Object does not need to be instantiated. Anything else? Anyone want to add anything to that? Where do we see static a lot?
When it doesn't have a return statement.
Not always. Void is usually what we use for lack of return statements, but static is often paired with void, at least in a main method in Java. We have public static void main. What does that static mean in a main method? Not precisely, but that's a good idea. It's a good thought. It basically means for all instantiations of this object, instead of having a copy of the thing, we're all going to refer to a singular point of existence. So we're used to writing, the way that I like to view objects is you have a class that you write, which we're going to call a blueprint. Did anyone in here start to see or have seen a blueprint analogy for the use of construction of objects? This is my favorite one to use because I think it's fairly straightforward and helps people to visualize exactly what's going on here. Before this building was built, Before we'd even begun construction, there existed some blueprint that represented the ideology of what this building would look like when it was finished. We had some diagram that outlined and portrayed what the construction of one of these looked like. And note that we could produce many, many Catalyst buildings based off of that same blueprint. We had to think about what it would look like once, and then we could make a bunch of those objects based off of that blueprint. So when we divide this into fields and methods that are going to represent state and behavior. Does that ring a bell? Interesting. No one's nodding their heads. Okay, so state in an object is just what is it constructed of? What are the building blocks that make up this object? Those are the fields, right? If we have a person object, that person is going to have a name and an age and a GPA and a salary and whatever else matters for a person. Eye color, whatever else. So the fields represent the state of the object. The methods, on the other hand, are things that that object can do. So a person can jump, a person can run. So these are all verbs that describe the things that that object can do. When you're writing a class, you're going to define what the fields are, define what the methods are, and this is going to become that object. It's kind of the blueprint for that object. When you make a class and you define these fields, do they have values? No. A person has a name, but we're not going to define in the blueprint what the name of a person is. If we did that, then all people would have the same name, and that's boring. All people would have the same age, all people would have the same GPA. We're defining the constructs of the person without defining what the values of that are. The behavior, on the other hand, is going to be the same logic, but you can also imagine, I like the idea of using your phones as this, or for this. Imagine that this is a blueprint for a phone. One of those methods would be, I don't want to state it, the power button. You use the power button and it's a kind of a binary, either turns it on or turns it off. So we're going to call it like on off. You press the button, and if the phone is off, it turns it on, and if it's on, then it turns it off. If you do this to your phone, does it affect my phone? Or your friend's phone? Or somebody else's phone? That means that when you define this function, this functionality, it's linked to that particular object, and not to every object that's ever been instantiated from this blueprint. So when we go instantiate and we say something like phone P equals new phone, and we call the constructor, maybe it has some stuff happening in here, we get back a particular phone. This represents my phone or your friend's phone, but it represents a particular phone. And that phone has particular state, and it has particular behavior that's based on this. But now the on-off method for phone P, if we wanted to, let's just call this power. Power button. If I say P dot power button, this would cycle it. If it's on, it turns off, but it only happens for this object P, not for every other one, because what happens is each of these methods gets copied because they don't have this keyword static in front of it. You notice that when we define all of the fields and all of the methods, the word static is nowhere to be found when you're writing a class. That's because each phone has its own fields and has its own methods attached to it. So all phones can signal the power button, but when you say P.power button, you're referring to a particular phone, and that cycles it on or off. So if we had a static method here, that would be saying that you can't call it on a particular object. And that all phones, some phone out here, some phone out here, some phone out here, all of that is defined by a single piece of logic. That all calls the same code. So if we made power button static, then when I pressed my power button, it would also affect all of your phones. Because all of that logic is the same for all objects. It all references the same place. Does that make sense? Has anyone seen an error thrown in Java that says cannot reference a static environment from a non-static method or vice versa? Usually this happens when you're trying to reference a static method from an object, like saying p.powerbutton on a static method, or you're trying to access something that is a instance method from main. You can't just directly call power button if it's not static from main, because there's no associated object to call it on. So which power button are you referring to? Are you referring to p.powerbutton or p2.powerbutton or p3.powerbutton? There's some ambiguity there because this is going to be replicated for each object that you make. So you can't just call power button, you have to call it on a particular object. So if you see anything like that, the first thing to look at is what object am I trying to call this on? Or did I accidentally make something static to just make the compiler happy so that it compiles? If you've ever done that before, when I was an undergraduate, that was the very first thing that I ran into in this and then had no idea why. I would just autocorrect something in my IDE, the compiler would be happy, and then I'd run it and get a runtime error. So there's always a reason behind it. So this is an important thing to remember if you get an error like that. That's the reason. Questions on this before I erase it? There's a little bit more to this slide, but I want to make sure everybody has a chance to talk about this process before we move on.
Wait, so it's the method that's tied to an object?
It's tied to all instantiations of that object. So I guess I can now.
All variations of the object, it's tied to.
Yeah, so for instance, I can use one more example here that will hopefully make this clear. When you write a main, so you have some driver class. Have we heard the concept of a driver class before? So it's kind of like a main class. It's going to have the procedural logic for making objects and interacting with those objects. So we have some driver class with some main. I'm just going to call public static void main stuff. And this is our main method within this driver class. Everything in Java is an object. Absolutely everything, including the driver class. By stating that this is static, it's saying that if we were to make and instantiate a driver class, all of those driver classes would refer to the same main method. You don't need to copy that main method because we have a bunch of different instantiations of driver. They'd all refer back to this one main method, which is why it is static. Did that answer the question, or is there more that I can do?
No, that clears it up.
So that is why main is always static. Other questions before we move on? Yeah.
So besides the name, so would you only ever use the static if you wanted to affect every single object?
Yes, and there are certainly some times where you want to do that. But if you're making something based off of the main, like every other, if you're in a driver class and you want some kind of other method in here, so some method that's a helper for the creation of objects or something of the sort, that will also be static because it's not attached to a particular object. So oftentimes in your driver class, a lot of the methods that you make will also be static. because they have nothing to do with actual objects. They have to do with the logic of dealing with objects, which is a one-time thing that is attached to the driver object. And this is one of the downsides to me of using Java, is you have to understand what static is and is not, because everything in Java is an object. The whole confusion stems from the fact that in Java, everything's an object. We can't just have some procedural steps to follow outside of the scope of what is an object. That procedure goes inside of an object as a method. So we need this keyword static to be able to say, if we were to make copies of this, we'd all refer to the same logic. We don't need to copy that logic. Really good questions. I'm hoping this is reasonably clear. It will probably come up again and again at some point. Question?
Can you like remember off any instances where this was had to be done this way, what was useful?
Designing like Java in that way.
Just something that needed to be static, just to the way that.
So let's see. As mentioned, anytime you have the same logic for each object that goes through exactly the same logic and doesn't need to be duplicated to only affect that object. So if you're describing a process that is not tied to an object, but it's embedded within an object's class. So that's necessary. It removes a lot of headaches for Java to force this process of everything as a class. And this is the main headache that it creates. It's always there are pros and cons. So you get one pretty big con and quite a few pros from it. But there are other programming languages that don't do this. C++ is an example of a language where not everything has to be an object, but it's still an object-oriented language. Java is really the odd language out in that sense. So as this is a Java class, I teach you the Java stuff, but if you move to another language, this will not necessarily transfer. Anything else? All right, we will move on. Rest of what's on the slide, we'll just summarize stuff that I've already said. Here's an example of when you might want to use static. All students at Eastern, if we were to make some kind of database of students at Eastern, attend the same school. There's no reason to define a string current school for every single student object at Eastern, because it would always be the same. And if we duplicate that Eastern student blueprint a bunch of times, we would be allocating memory for every single current student string for the number of students that are at Eastern, even though they're all going to have the same value. Current school is always going to be Eastern Washington University. So rather than duplicate it a bunch of times for each object, we could just have one place in memory that stores the string Eastern Washington University and have every student object point back to this single string. And we don't use the memory to duplicate it for each student object. So that would be a place where you might want a field that is static, because every object would refer back to a single point in memory rather than duplicating that memory. And we went over why main and driver classes are static. And then we talked about accessing non-static contexts from static contexts and why that might be an issue. So if you see that and you don't know what's going on, please come talk to me. I'd be happy to explain what the error is and how to intuitively think about it. All right, next. Questions about static? How do we feel about static at the moment? Question?
And what's the difference if you could want to use maybe like Eastern Washington University and use that as a constant?
Yeah, const in C++ is very similar to static in Java.
Yeah, because my mind's doing C, so
Yeah.
statics works differently. So if I put a static on a variable like an integer, I can call that same exact integer and I can manipulate it, will store the last known value.
Yes, yeah, if you add the ability to manipulate this string, it will manipulate it for all objects if it's static. Whereas const is more like static final in Java, where if it's constant, it's expected that it's not going to change.
Yeah, that makes sense.
Yeah, so it's probably more synonymous with the final keyword in Java, but it borrows some things from static. But static and final are very different things. Maybe I should go over that as well. Do we know what the final keyword represents? So if we have an object that is represented as final, then it is unmodifiable. You cannot change it. So this is very different from static that says all objects refer to a single instantiation of something. Final just says we expect that this will not change, and it cannot change. It will throw a compiler error and your program will not compile if you try to modify something that is final. All right, Java packages. Have we made a class inside of a package before? Yep, makes sense. So packages exist in Java to group related classes together. They give you some level of class hierarchy. It's especially useful as we start talking about testing, because we're going to have multiple different classes, and usually you're going to make a test class for every object class that you have. So we want to have packages to give that some kind of hierarchy and some kind of sense so that you group related classes together, like the class and its tests. Also inheritance hierarchies, if we want to make superclasses and subclasses and say these classes are related in some sense, then they belong in the same package. Note that there's no restriction in Java about having classes with the same name, as long as they're not in the same package. You can't make a person class and another person class within the same package. But if they're in different classes, in different packages, you absolutely can. That can be very confusing if you do that, but it's sometimes useful to be able to name something the same. What this helps you do is if you have a very large project that has lots and lots of different files and different file hierarchies, it allows you to break them down into components so that you have an organization system for your large project. If you want to define, have we seen the protected keyword before? Know what that means? So the two big ones that you'll have seen before are public and private. What do these mean?
Private is exclusive to that one class, while public is available to other classes.
Yeah, if we have some method, for instance, that wants to read or write to a field within a class, it can do so if that field is private. But as soon as another class tries to modify something directly, you have to go through a getter or a setter. We call that encapsulation to be able to do that. So privacy means that the only logic that can manipulate it is within that object itself. Think of it like, I am the only person who is allowed to feed myself. If anyone else tries to feed me, that's weird. So that's a private method where I say I'm the only person allowed to do that. Otherwise, it's weird. Public, on the other hand, is freely accessible from anywhere. So when we introduce this concept of packages, we need to introduce another level, another privacy level. So protected is between public and private. It says it can be freely modified from any class within the same package. So it's public within the same package, but it's private for anything outside of this package. So it's a package level public-private. And that way it allows you to make some inheritance hierarchies where if you need a subclass to be able to modify the superclass, that's usually a terrible idea, but the protected keyword would allow you to be able to do that and maintain privacy from objects that are not within that same inheritance hierarchy. Questions on the protected keyword or Other aspects of packages, I guess I have a little bit more here. Just explains protected. If you're going to import something, this is the other place that packages come in. You import the project.thepackage.theclass. So if you ever do something like import java.util.scanner, for instance, Java is the project, all of the code that comes with the Java language. Util is the package, all of the utility classes for the Java programming language, and then scanner is the exact class that you're importing.
Would it be possible to exclude the class and import the whole package?
Yeah, if you do project.package.star, then if you've ever used the star, this stands for the wildcard, and it means that anything that could go here, every single class that starts with the project java.util.something, doesn't matter what that is, it will import it. You'll want to be somewhat careful with wildcard use, because if you're looking for a particular thing, there are some things, like, has anyone used Linux in here before? Terminal Linux? Do we know what the RM keyword does in a Linux terminal?
Remove.
Yeah, it deletes things. What happens if you RM star? You break everything, because Linux does not prevent you from doing this. Never type this into a Linux terminal, you will hate yourself. You can also remove star.star, which will remove anything with any file name with any suffix, like .doc or whatever file extension you want. Linux does not prevent you from doing this. It says if you're going to do this, you must have some reason for doing this, and I'm not going to question you. With great power comes great responsibility. So be very careful with wildcards. They can ruin your life. All right, jar files. Have we seen jar files before and know what they are?
For methods and stuff that are used a lot, you can import them into a project and use them.
Yeah, they're basically, it's an executable form of Java code. It's basically an export of some code. And it allows you to run that code, use that code. So if you're going to export your own program to be used by another program, you export with the .jar extension. It is archived like a zip or a tar or a rar. Those are all file extensions that are archived. So it does have a smaller file size than your class. You can create jar files, view jar files, extract jar files, and run an application directly from a jar export. So oftentimes when you're done writing code, you will export as a jar and upload either the .class if it's the actual source, or the .jar. It's kind of like an executable in Windows where you can actually directly run the application from it. You can make these from an IDE with the export command. So if you file export, then that'll allow you to create the jar file. It can also be made from the command line if you're operating things from the command line and not necessarily from an IDE. So frustrating. I have a single slide left, but we are out of time. So we will come back tomorrow for that. And then we will probably have some time for some practice problems tomorrow. So I'll see you then for that. Yeah. Have a good day. You too.